gone through on in the latest version of etcd to make it nice and seamless to integrate in process. So I don't know whether or not we wanted to have a configuration or a flag to potentially have an embedded version of etcd in the API server for some people that want to have that configuration. Because that allows you to get rid of the caches, everything's in memory, so the queries will be fast. You get rid of that cert over the wire, so you don't, for people that have that configuration. So there's a lot of advantages, but there's also a trade-off in the fact that your API servers will have to be deployed in groups of 1, 3, or 5. I don't know what your thoughts are on that.
So I think that, yes, I agree that some caches we may be able to get rid, but it's not that all of them. So for example, like this cacher thing, I think it should still be, it will have to still be there, because it's like, if we are serving waters, then in etcd obviously we have serialized data, and deserializing it, like if we will just pipe waters directly into etcd, which would be the case if we don't have this cacher, then it would mean that we will be deserializing the same data over and over again. So it's not that we will be able to remove every caches that we have. So,
I see that.
So I think it can potentially have some advantages, but I wouldn't like to be at the point where this is like the only thing. Like we can consider like making it an option, but it should be an option. I'm not sure if it should be default option or non-default, but it should still be possible, I think, to deploy it relatively easily, like as a separate process. That's
I agree. I'm not saying like we shouldn't it's the one true path. I'm saying there's obviously a trade-off there, but if you wanted like a simplified HA deployment, this gets you there a little bit easier. If you're trying to manage the number of bits that you're trying to deploy, it makes it easier, and there's also some slight performance advantages there too. So
yes, one thing, there's just basic hygiene with a database around backups, and there might be other maintenance tasks where you go behind Kubernetes back to get at this stuff. And so both of those issues might be more difficult if we do it in the embedded case.
So we actually, full disclosure, we actually did this in OpenShift. And you can provide these same endpoints that you normally would provide. And what we did is we routed them through localhost. So that way, if you're on the machine, you can do all the etcd operations, but you have to be on localhost.
Interesting. Okay. I think it's worth looking at. I think, it expands the test matrix yet again, test matrix.
That is true.
And it's yet another sort of install option for people to wrap their heads around.
I think
if we were going to go to the sort of hypercube where it's just one process that sort of brings stuff up, I think that starts to make some sense. But as long as we still have separable and we have to do like bootcubey type of things, I'm not sure how big of a gain it ends up being.
That is true. There's going to have to be management there. I guess the one big advantage you would get rid of is you would get rid of the cert configuration and the hop over the wire between the API server and etcd when it's in a clustered fashion. So that's.
Yeah, I mean, the cert is definitely a sticking point, but yeah, and cert rotation is something that we haven't dealt with in a great way yet.
Yeah, I think that also like a good data point for it would be how much work it would be, because like if it's like week of work, then we should definitely try doing it. If it's like half of a year, then maybe it's not worth pushing.
They made it really seamless. I can point you at the reference of how they did their integration, but the piping of the config to localhost, that's going to be extra configuration to make it work right.
Mm-hmm. But I think it's worth maybe bringing up the cluster lifecycle, because this is going to have a pretty big impact in terms of the management experience.
Yep.
Yeah, good point. Yeah.
That was the only thing I had on the high level. How's the data looking for 1.6, Wojtek? Good?
It's pretty good, yeah.
Have you guys seen this stuff about the node? There's some issues people are node not ready issues that people are seeing. I mean, have you guys seen that at any large scale numbers where nodes just kind of look like they're not ready for a long period of time? Somebody put a patch in the other day. I don't know whether it's a regression or what. I don't.
So I'm not like we've seen some in some number of nodes, but that are unready. But it was mostly like because of API QPSs being starved, and kubelet not being able to update the status itself. But it was like during it was a few weeks ago.
So this actually,
but it's obviously depends on the load. So if you have some if you generate some very high load on kubelet, or for example, like if you create a lot of secrets or config maps for pods that are running on this kubelet, and this kubelet will be periodically retrieving this data, it may potentially affect the ability to update node status. So it very highly depends on the load that you and then on the pods that are running on this node. If this is the problem that you are observing, because it can potentially be something else.
So it's just that the not ready endpoint it's just because that I don't even know how not ready works. I mean, I guess it assumes that if that comes from a kubelet not being able to talk to the API server, or the API server not being able to pull it or something.
Sorry, can you repeat?
So not ready winds up being a measurement of, is that reading from a healthy, or is it reading from I don't even know how that's measured by the API server once it on a running kubelet.
So the not ready node is basically if kubelet won't be able to send updated status within I don't remember 40 seconds or something like that, node controller will mark it as unready.
Yeah, okay, makes sense. So that's why you're saying it's QPS. Okay.
So we were with some node, especially when we were having a lot of config maps and a lot of secrets and stuff like that on a given node, we've seen that. But it wasn't that the kubelet was unready for a long time. It was just flapping between ready and unready. So it might be something completely different than you are observing.
Well, I mean, there is, distributed systems 101. There's a balance between detecting when things are actually dead versus thinking they're dead, and sort of responsiveness versus robustness. And so there's no right answer here. So I mean, we could tune that, right? But it would probably make it be harder to detect when things are actually dead.
So there was you brought up a point that I think is worthwhile, or it's orthogonal to the original topic, but it was the question of our QPS limits are still really fictitiously low given all the changes we've made over history. I actually have a tool right now that I'm working on to rip through and do a ridiculous number of queries. And I'm a little afraid of how hard it could hit a loaded system. So our QPS limits, are they in scope for 1.7 to start to update them now that we're going to be at the 5,000 node range?
Maybe, I don't know. I think that it's important. I'm not sure how much time we will have in Google to look into it.
Can't we just kind of ballpark it based on cores or memory or nodes or some right now they're just hard coded, right? That's kind of the worst case scenario. Can at least be sort of whatever is hard coded be normalized to the amount of memory in the API server or something, some other metric. So it's a reasonable guess to start off with.
It's like Waj's magic calculation for deserialization cache.
Yeah, can we just do
People don't know that magic underneath there, but I've seen it. So.
I don't know. Is that crazy talk? I don't know. Maybe it is. I don't know.
No, it's a reasonable expectation to have. But it's total fanciful. It's like we're trading one magic number for a different magic number that's slightly variable.
Yeah.
I think it's reasonable to up the QPS limits to some value, but it needs to be qualified, right? That's the problem.
Yeah, I mean, what's the biggest limitation on QPS? I mean, is it CPU? I don't know.
Originally, it was CPU. So, like back when we put these limiters in, it was way back in the 1110 timeframe days. That was the original limiters, and then we bumped them, I think, in 11. And then we kind of left them there over across multiple releases. And in the 1.2 timeframe, what was it, like a 300 node cluster could pretty much completely destroy a what's it called? The CPU on a master. So that was the original problem. Is just that having too many queries in flight with all the encoding and decoding that was going on was woefully inefficient. And that was just the governor that was placed on there.
Yes.
Yeah, I think I remember those. I think we had plots for that or something a long time ago.
Yes, but definitely for some components, it should be easily bumpable now.
Yeah, I'm mainly concerned with the API server because I'm writing something that's gonna just query the heck out of it. So
the question is like how much we can potentially bump it in kubelet, because in large cluster, like bumping, for example, in like 5,000 node cluster, bumping QPS by 1 in kubelet means like 5,000 QPSs. So,
well, I think just bumping the API server alone is a reasonable thing.
Yes, that one.
Maximum flight connections, yeah.
Yes, that one I agree. Yes.
Yeah, I think this is all for the API server that we're talking about.
That's the only things I have.
Who originated this question about the KPS limit?
I did. It's more like max in-flight connections than the actual QPS limits themselves from the components. Although we could revisit them for the core components. I agree with Wojtek on the kubelet side.
So basically, it was decided because we saw some things catastrophically happening, but we've never considered like some sort of test or some sort of I don't know, benchmarking to figure out what could be done, how we can optimize this basically.
We could probably easily write a benchmarking tool, which is not a bad idea, honestly, to basically hammer the API server in an end-to-end test, because it's just client stuff. So you could load etcd up with fake data and just constantly have a client querying the heck out of it and see where, what's the threshold by which we, exceed some measure of okayness. Like we'd have to specify that. Yeah. Like if we exceed like 4 cores, then game over, but or something to that effect, right?
I have it on my to-do list for more than 2 quarters now in my backlog, and it was like always deprioritized by our PMs. So.
What were you saying there, Wojtek?
Sorry?
What were you saying?
So I'm saying that like this benchmark for etcd plus API server, I have it on my to-do list on my backlog for like more than 2 quarters now, and like it was always deprioritized by our PMs.
Gotcha.
But yes, I definitely agree that we should do it at some point. Maybe I will have time to like at least contribute to it.
It seems like this is another topic that fits into the SLOs, right? Kind of naturally.
Yes.
Okay. And has there been any progress with the SLOs?
Marek is on vacation now. I was pretty busy with 1.6 also, so like I think that except from like what we were discussing 2 weeks ago, I think that Marek sent it like wider to the whole GK dev, I think. Like sorry, not GK Kubernetes dev, and I think there weren't any concerns about it that I'm aware. So I think that we he should be back on Monday. So next week is actually KubeCon. So probably in 2 weeks we should like make a final decision if it's like we are fine with that, or say that like if no one will object until then we will assume that it's like okay.
Yeah, because I mean these type of like not only the SLOs, which is super important for the long term, but these other benchmarks are also good because right now we kind of ship something out in the field, you know, and it's got governors in the place, and users don't understand why things time out or why issues exist, and it'd be nice to have it more formalized, honestly.
I completely agree. Yes.
In the meantime, where do we place that information? Where do we inform in an open and easily accessible way, like how the decisions were made and why they were made the way they were? Is it something that we've ever like really paid attention to?
Ideally, we would have some type of like document for the scalability SIG that outlines here are the knobs. Here's the history behind them, so that somebody could go through and new people that come on board could understand it. But we've never actually done that. I think it's probably worthwhile for someone to take an action item to do that. I am swamped though.
Fair enough. Add that to like to agenda.
Do we want to possibly do an auto QPS with an end-to-end for 1.7 Tim or anybody else? Do we have? Do we want to try that, or do we want to just bump the number as is? Or
I think if we're doing jurisprudence, if we're doing what we think is right, we would do both.
Yeah. So we may be able to help with that on our end, because I know that's something that these guys care about for some of the scale stuff that they're doing in OpenShift. If nobody else wants to work on it. All right. Okay, well, I mean, yeah, does that sound like a decent idea for us to possibly grab? Or does somebody else want to do it? The auto QPS thing alongside an E2E that hammers at CD.
Auto QPS.
I think you'd probably want to focus on max in-flight connections first, right? That's the most important one.
Yeah. The max in-flight. Oh, okay. Yeah. So max in-flight is a separate option. Let me see. I don't remember how these options work anyways, actually. It's been a while.
Is this something we're proposing? Is this something that already kind of exists, just hasn't been implemented?
Max in-flight is there, but I don't remember looking right now.
So I don't have any objection if you want to work on it, Jay. I think probably Wojtek or Merrick would review the PRs for any end-to-end on that side. And if you've had it on your list for a while, do you have anything written down, Wojtek, on your tests that you planned, or no?
No, not really.
Yeah, it was something that was an issue for last time in terms of setting that number. So I don't. If the idea of automating any of this is something we're interested in, then I think we can play around with it.
It will be some kind of different E2E because we probably don't want to run controller manager and kubelets and anything like that. We will just want to stress API server plus etcd, but yes, in a way it's.
So the end-to-end, certainly, yeah. We definitely, I think, all agree on the end-to-end. And the only question I have is what we think is the most conservative choice to automate first in terms of coming up with a good guess as a command line option, so the user could say, look, I
think that I agree with Tim that those max in-flight connections is probably the first.
And so then that specifically is what we'll look at, and then the rest of the stuff can come along later.
Yeah.
Yeah.
Any more items people want to talk about today?
Oh, yeah. I mean, I guess the only other thing was rolling back to the node issue. I think this end-to-end, this hypothetical end-to-end that we're talking about, so I don't know if we want to measure the not ready stuff also as a measurement of cluster failure in this end-to-end or in another end-to-end, but it seems like it might be something that it would be good if we had a test for it. Well, actually, there's two scale tests that we actually want that. And the other thing is a disk test. I don't know if we do anything where we scale storage on disks. That could be disruptive, but I don't know. But is there any plan upstream for stressing disk out? One is the first question, and then second of all, is there? Do we think we should actually have an E2E for the not ready stuff?
I think not ready. We are.
Or we should measure that maybe in density or something, like as part of the density tests, see if the not ready gets tripped.
So I think that we are, or maybe we are only like, I'm sure we are testing something about not readiness, but it might be only at the end of the test potentially, which it means that it might be worth like doing something more there. Regarding like disk, I think that yes, we definitely want to do at some point, but we are still more focusing on a little bit, I would call it stateless workloads than stateful, but yes, I did like, whatever that means, like medium term or like long term or more short term, we should do it at some point. Yes, for sure.
Yeah, those are things that we kind of need to hear.
So the problem with disk is you probably want to talk with the node team, and there are no fences for disk. So if you started to do like disk stressing things where you have multiple, if you're actually exercising local disk versus like attached volumes, and there's also, it's two parts, right? There are no governors that exist for disk, and there are no governors for network. So you can kill it in two ways, right? Mm-hmm. So you can kill the local disk by having too many things writing concurrently. You can kill the network and basically denial of service attack the control plane by having too many PVs that exercise and stress that way too.
Yeah. I'm just trying to get this down. Yeah, I mean, it's kind of an ugly thing, testing story, and it's definitely disruptive.
You can add the tests. I just don't know who's going to run them and when and where.
Yeah, this is one of those weird E2Es that we're trying to avoid adding that nobody actually uses, but that sits there, you know. Is there is the idea of, I mean, we do have some external scale tests. I mean, maybe that would be better in another external repository. I mean, our team kind of is working on that. I can talk to them and see. All right, well, that's kind of, I think, enough for us. We can follow the rest up in Slack or whatever. Details. The most important thing was determining whether or not we're interested in that stuff.
Okay, any more items? I'll take that silence to mean no. It's 9:30 exactly. Thank you, guys.
Thanks. Yeah.
Okay, thanks, guys.
Right.